Welcome back to Further Solutions Academy. Further Solution Academy. On this video, I'll be walking you through on diagonalize of a matrix. How do we diagonalize matrix? Don't forget to share this video, subscribe, and if you have not subscribed before, make sure you subscribe and share. Now, on this video, I have this problem. It's a problem that somebody sent to me. Although at this point we have a lot of videos on eigenvalue, and eigenvector. And when you have this type of question, how do we solve it? Let's go on. Solution to this problem. Now, the first thing you need to know about this question is that it's a very simple question. There are two ways of getting our characteristics polynomial. That is step one. Step one, you get your what? Step one, you get your what? Characteristics polynomial. Now, characteristic polynomial, how do I get it? That is the next thing I need to ask myself. Polynomial. Now, how do I get this thing? How do I get characteristic polynomial? The first thing I would know, there is a way of doing it. I can go in a normal form, which is traditional form, and I can also go by saying that although just so that I can say that I minus what? Minus my a, which can also be equals to minus 4, 1, minus 1, 2, 5, minus 2, 1. Sorry, this one will be what? That will be c minus 5. And this one will be minus 2. This one will be minus 1. And already minus. That will be minus 1. And this one will be, that will be t minus 2. Now, that is one way of going about it. Now, the best way to do this thing is that I will try to approach what is called, let me use this particular one. I can call it lambda. This allow. I think we are used to lambda. Let me convince you guys. Now, I can turn to lambda. Now, it means with my lambda, I can say that my lambda squared, lambda cube, minus trace of what? I think I'll be having trace of a of lambda squared plus a11 plus a22 plus a33 bracket of t minus determinant of a, which is equals to 0. Now with this, I can easily get my polynomial, characteristics polynomial. Now the first thing I will do is that when we talk about my t, I will have my lambda squared. What is my trace? My trace, note this, sorry. Oh, where's my board? Now, note this, that when you talk about trace of A will be equals to addition of the diagonal. Addition of this is known as trace. It means I'm having plus 5 plus what? Plus 2, which is going to be 11. And if I'm talking about my A11, my A11 will be equals to, now I'm talking about my A11 will be, now how do I get my A11? This will be my A11. It means at this point we're talking about this. It means I'm talking about 5 minus 2, 1 and 2. Now when you do this, I'll be having 12. Now my A22 will be what? At this point I'm working on this part. It means this part and this part. I'll be talking about 4 minus 1 and 1 and 2. Now by finding that will be 8 and plus 1, it will be 9. Now if I'm talking about 833 will be equals to my 833 is on this part. I'm talking about this, which will be left with what? 4, 1, 2 and 5. Sorry for the noise pollution. I'll be having 20, which is going to be 18. Now when I add them up, plus A11 plus A22 plus A33, which is going to be what? 12 plus what? Plus 9 plus what? 18, which it will be equals to what? By solving, it will be equals to 39. Now, the last part of it, which is going to be my determinant. Determinant of A will be equals to, how do I get my determinant? You know what? 4 into bracket of 5 minus 2, 1 and 2, and the minus 1 into bracket of what? I'm talking about 2, 1 and minus 2, 2. And I'm talking about minus 1 into bracket of what? Now, I think I'll be having 2, 1, 5, 1. Now, for instance, when you do this finish, you are expected to have determinant of A to be equals to what? 45. Please, to do that by yourself because of our time. And okay, now we are to expect to have 45. Please, after you do that, you just do the determinant, which is going to be 45. The next thing I will do now is that I want to implement this particular trace, which will be lambda cube minus, what's our trace? Our trace is 11 lambda squared and plus what? Now, this one will be equals to a 29 lambda, and the last one will be what? Minus 45 equals to 0. Now, I want to move on to this thing. I will look for the factor of this number, which is going to be what? Plus 5. 5 is one of them. 3 is one of them. Now, I can say that when my lambda is equals to what? When my lambda, now, when my lambda is equals to 3, let's see what we get. I'll be having 3 cubed. Everything will be equals to 0. You can see this one will be 27. This one will be 9 times, that will be 99. And this will be, now, everything will be equals to 0. Since I know it will be equals to 0, it means my lambda is equals to 0. Now, by syntactic, I can go by syntactic method. Please, how do I go by my syntactic? If you want to learn about syntactic method, you can go to our platform. Now, it means 3 is one of the factors. Now, I can say that 1 minus 11, 39, and minus 45. Now, the first thing is I'm working on minus, which is the syntactic. I will drop down 1. Now, this times this, I will be having minus 3. Minus 9, I mean this would be equals to, it means this minus 11 minus, which will be what? 11 and this thing, it will be 8. I'll be having minus 8. This times this, it will be equals to 8 times 3, it will be 24. I'll be having plus 24. Now, I'm having 24 minus, it means 24 minus 39. Am I correct? Yes. That'll be 5. That'll be 1, which is going to be 15. Now, which is I'll be having 15. This times this, it will be equals to minus 45. Now, when I had it will be 0. It means I'm talking about lambda minus 3 and lambda squared minus 8 lambda plus 15, which is equals to 0. At this junction, if I should factor this with the knowledge, I think I'll be having lambda minus 8 lambda plus 15, which it will be equals to, it will be lambda minus, okay, lambda 5 and lambda 3. That is what we factor with it. You can try that by yourself. Now, by so doing this, I have this. It means I have lambda 3 squared and lambda minus 5. Now, the next thing I want to do is that it means my lambda is equals to 3 twice, and my lambda is equals to what? 5. That is the implication. The next thing I want to do is that when my lambda is equals to what? When my lambda equals to 3. Now, what I will do is now I will come to this part. When my lambda is equals to 3, I'll be having, it means I'll be having, it will be minus 1. When my lambda is equals to 3, minus 1, and 1 and minus 1. Yes, I will be having minus 2 and 3, it will be, that will be minus 2 and minus 2. And this will be equals to minus 1, and it will be 1. I think that is going to be, yes, that is going to be, that is what is we are going to be. It's going to be now. Oh, yes. Now, this is going to be 1. Sorry, I made a mistake. This is 1. Now, for me to have that, I can now say that, row reduction. The first thing I will do, I can say that of R2, this is going to be minus of R2. And by so doing that, I'll be having, which is going to be equals to minus 1, 1, 1, 1, 1, and minus 1, 1. Now, by so doing that, I'll be having that. Now, if I do the more row reduction of this particular function, okay, by so doing that, I'll be having what I'm doing. Okay, I think I'm not making a mistake. Now, by row reduction, I'll be having, if I say that was row 2 equals to row 1, row 2 minus row 1, row 2 plus row 1, okay, row 2 plus row 1, yes, okay, row 2 plus row 1. What should we have? Now, when we have that, we will be having that is that when lambda is equals to 5. Now by reduction, this will be equals to, it will be 1, 1, 1, 0, 0, 0, 0, 0, 0. Please, when you do your reduction, that is what you are expected to have. Now, let's leave this particular one like this. Now, since we have that, we can now continue by saying that, now I can say that my x1, x2, x3 equals to 0, plus. Now, we are talking about x1 here, s2. Okay, we are talking about x1, which is the first lambda. Now, that is the first thing we are talking about. Now, you know that is twice the function here. Now, okay. Now, at this junction, I can now say that I have this, which is going to be s2. Okay, what can I do to make my what? To my function to be, we are talking about twice of 3, which is going to be twice of 3. Now, what should I do that will make this thing to be more realistic? What I will do is that I will have my x1 equals to minus x. This is going to be minus, sorry. This is going to be minus, sorry. Sorry, this is going to be minus. Now, my x1 will be equals to minus x1 plus minus x3. Now, which is, by implementation, it will be x1 minus x2, which is 3. Now, by so doing this, I'll be having something like x1, x2, x3. Now, which it will be equals to minus x2 plus x3. Now, which is going to be what? It will be equals to s2 and s3. Now, by so doing this, it will be, by implementation, here will be what? Minus s2, and 0, and it will be plus what? S3 is 0, S3. Now, can you see what I just did now? It means I'll be having my V1, it will be equals to, let me call it M2. M2 will be equals to minus 1, 1, 0, and my M3, it will be equals to 1, 0, 1. That is the first thing I will need to do. Now, let me move on with this. The next thing I want to do is that I want to get my M1. My M1, it means when my lambda is equals to what? Now, when my lambda is equals to, okay, this is twice of, this should be, okay, M2, M3. Okay, now I want to get the other one, which is when my lambda is equals to what? Now, at this junction, I will just have what? When my lambda is equals to 5. When lambda is equals to 5, what I will just do is that I have lambda minus 4, I have minus 1, 1, and I have minus 2, and I have lambda minus 5, and 3, and I have minus 1, lambda minus 2. Now, when my lambda is equals to 5, by so doing this will be equals to 1, minus 1, 1, and this one will be 2, minus 2, there will be 0 and 3, and this one will be minus 1, which will be what? 3. That is what we have to get at that junction. Now I want to do the reduction of this thing. By reduction, which is going to be by reduction, I'll be having minus 1, and I'll be having 0, minus 2, and 4, which is going to be R2. I'm talking about R1, R2, R3, R2, and R1. R2, R3, R1. Now, by so doing this, it means I'm saying that my R, I'm taking my R out of this, which is going to be my R2 plus R1. No, my R2 plus R1. If I have my R2 plus R1, it will be 0, it will be minus 2, it will be 4. And the next thing is, if I have my R3 minus R2. R3 minus R2, it will be 1 minus 1, 1, 0 minus 2, 4. It will be 0, 0, 0. That is my R3 equals to R3 minus R2. Now, for me to have that, it means I'm saying that I can also say that 1 all over 2 of R2, which it will give us 1 minus 1, 1, 0 minus 1, 2, 0, 0, 0. Now, for me to proceed with this now, I can say that my what? S1 minus S2 plus S3 equals to 0. And my S2 minus S2 plus 2S3 equals to 0. Now, that is the first thing I will do. By so doing this, I will have, now I can call this as my x1 equals to now my x1 equals to S2 minus S3. Now I think my S2 can be equals to 2S3. Now, by so doing this, I can now interpret my x1, S2, S3, which it will be equals to x1, S3, 2S2, S3 and S3. Now, which it will be equals to what? 1, 2, 1. That is my, it means I'm talking about, this is my what? My M1. Let me just M3. Now, M3 equals to what? 1, 2, 1. Now, this is going to be M1, M2, and M3. Now, the next thing I want to do now is that I want to find the what? Now my P. What will it be my P? My P will be equals to, what is our M1? M1, M2, and M3. Which is, P will be equals to, what is my M1? I have minus 1, 1, 0, 1, 0, 1, and 1, 2, 1. That is my P. Now, I want to find my P inverse. My P inverse will be equals to P of 1 of I, which is going to be P of I, which is going to be what? My P inverse will be equals to, I have minus 1, 1, 1. I have 1, 0, 2, 0, 1, 1. 1 is 0, 0, 0, 1 is 0, 0, 0, 1. Now, what I will do now is that I want to find the inverse of this particular matrix. The first thing I will do is that, I can decide to say that my R2 equals to R1, R2 plus R1, and my R3, can be the same thing, which is I don't have any problem. Let it remain R3, which is I don't have any problem with it. It means this is going to be what? This will be equals to, don't forget that anything I'll get here is called P inverse. That is what we need to know. Now at this junction, I'll be having minus 1, 1, 1, and 1 is 0, 0. This one will be what? That will be 0, 1, 3, 1, 1, and 0. Now, this one will be 0, 1, 1, 0, 0, 1. That is what we are going to be talking about there. Now, the next thing we need to work on is that we need to get this place to be equals to 0. Now, this place to be equals to 0, it means my R3 can be equals to R2 minus R3 minus R2. R3 minus R2. By so doing that, I'll be having minus 1, 1, 1, 1 is 0, is 0, 0, 1, 3, and 1, 1 is 0. Now, at this junction, this and this is going to be 0, 0. Now, this minus this, it will be minus 2, and this minus this, it will be minus 1, and now this is going to be 0, that will be 0, R2 minus R1. Now, we have this, and this, it will be minus 1, and this, it will be what? 1. Now, can you see I'm trying to find the inverse of the given matrix? Now, by so doing this, I can continue by having this to be 0. I need this to be 0, this to be 0, this to be 0. That is what I'm trying to work on now. I can say that my R1 will be equals to R1 minus R2. And my R3 will be equals to, okay, let me leave my R3 for now. I don't even have any problem with my R3. Now, it means my R2 will be equals to R. Okay, let me first do this part. Minus 1, that will be 0. That will be minus 2. This is going to be minus 1. That will be minus 2. And this would be, that will be 0. That will be minus 1 and 0. Now, and the next one will be what? Is 0, 1, 3, 1, 1 is 0, and is 0 is 0, minus 2, minus 1, minus 1, 1. Now, that is what you just need to work on. Now, the next thing is, I want to turn this to be 0. For me to turn this one to be 0, I must have my R1 will be equals to 2R1 plus 3R1 plus 2R2. Now, by so doing that, 3R1 plus, which will be what? Minus 3 is 0, and this one will be 0, and we have 0, and this one will be what? 2 and 3. That'll be 2, that'll be 1, and 0. Now, it will be what? 0, 1, 3, and 1, 1, 0. To be 0, 0, minus 2, minus 1, minus 1, 1. Now, at this junction, I want to turn this to be 0. Now, what I will just need to do is that I will need to my R2 will be equals to 2R2 plus 3R3. Now, 2R2 will be 3R3. Now, at this junction, I will be having minus 2 is 0, 1. Is 0, is 0, 1, is 0. At this junction, I will be having, this will be 0, 2R2. That will be 2. That will be 0. And this one will be what? 2R2 plus R3. 2, that will be 2 minus 3. 2 minus 3, that will be minus 1. And this one will be what? 2 minus 3 also, minus 1. And that will be what? 3. Now, at this junction, I'll be having is 0 is 0, minus 2, and minus 1, minus 1, 1. Now, at this junction, I will divide all through by what? Minus 1 all over 3 of R1, 1 all over 2 of R2, 1 all over 2 of minus R3. Now, at this junction, I will be having 1 is 0, 0, 0, 1 all over 3 minus 0, and this one will be what? Is 0, 1, 0, minus 1 all over 2, minus 1 all over 2, 3 all over 2, and here will be what? Is 0, 1, and minus 1 over 2, minus 1 over 2, 1 all over 2. Now, at this junction, I can now say that you can see that it's very simple. You're just computing. Now, at this junction, hope I'm not getting off. No. Very correct. Very, very correct. Okay. Now, I can now say that my P inverse is this particular path. Now, it means my P inverse, it will be equals to, my P inverse will be equals to, hope I'm not making a mistake here. With what I've done here, hope I'm not making a mistake. My P inverse will be equals to 0, 1 all over 3 minus 0, and 1 all over 2, minus 1 all over 2, 3 all over 2, and 1 all over 2, 1 all over 2, and 1 all over 2. Now, that is my P inverse. Now, when you have to diagonalize, how do I diagonalize a vector? You are just to make use of something like this. My B, some people use D, of P inverse of the given matrix of P. That is what you are just to move on. It means my P, what's my P? 0, 1 all over 3 is 0, 1 all over 2, sorry for this line. Okay, minus 1 all over 2, 1 all over 2 minus 3 all over 2, and minus 1 all over 2, minus 1 over 2, minus 1 over 2. My A is the given matrix. What is our given matrix? I've finished. I have 4, 1, minus 1, 2, 5, minus 1, 1, 2. And the last part of it is what? Is a P inverse. What's going to be 0, 1 all over 3 is 0, 1 all over 2, 1 all over 2, 3 all over 2, and minus 1 all over 2, minus 1 over 2, 1 all over 2. That is all. That is all. That is our P equals to. Now, by doing this, that is what is called diagonalize of a vector. I may not be able to finish this because of our time. You can see the first thing I find the characteristics polynomial. The next thing I find the eigenvalues, which is 2 repeated. I mean, 3 was repeated, 3 twice with 5. From there, I got my eigenvector of each of the eigenvalue, which is 3, 3, and 5. From there, I slot in to get my P, which is my P, the eigenvector 1, eigenvector 2, eigenvector 3. From there, I find the inverse of what? Of the P, which is, I have my P inverse, which is by having this and this. And from there, I go to this part. From there, I move on to this. I do the what is called the row reduction, which is looking for that. I got my P inverse to be this. From there, this is what is called the diagonal of the what? Of the given matrix. And by this time, I can now multiply and move on. And that is all about this. Once again, you are home with Further Solution Academy. Thanks for watching.